to x1, that our x1 is 0.5 in this case. Always is 1. The next is our x value. Remember, our x value actually is start from 0.5, then 2 and 3.2. So for this range here, 0 to 0.5 is always is 1. Then the second range here, 0.5 to 2, then will be equals to this. So nx1 is a number of observation of x1 that is we found just now actually is 1. So this is 1 over, and this R1 is a reset for the x1, that is 4 we found just now. So this is 1 over 4, and you will have 0.75. So how about next? The next, that is for the range from 2 to 3.2. So in here you can see that this actually we have calculated, that is we try to use this recursive formula. So we have calculated this. So this is a 0.75. This whole thing is a 0.75, and you try to multiply this item. So the nx2 is a number of observation for x2, that is we found is 2 just now. So we have 2 here, and this is a reset for the x2. So we found that is 5. This is 1 minus 2 divided by 5. So that means here will be equals to 0.45. So for the last interval, that is from 3.2 to infinity, then we can use this recursive formula again. That is for the first section we have counted, that is 0.45, and we try to multiply 1 minus nx3 divided by r3. So for this number of observation for x3, we found that is 1, and the r set for x3 that we found is 5. So this is 1 minus 1 over 5, and this will give you 0.36. The whole working will be this. You could see that for the first interval here, it's always start from 1, and for the last interval, you could see that it's 0.36, which is not 0. But usually for the survival function, for the last interval here should be 0. But for this Kaplan layer, this is not necessary to be 0, because this is just approximately for the calculation.
Okay, class, this is example 1, how we want to calculate the reset and also the Kaplan layer. So now this is your survival. Because this is discrete, therefore we have different range. So if you want to calculate the probability of the survival, let's say at 3, okay, at 3. So the 3 is false on this. So the approximate probability of the survival at 3 is about 0.45. Okay, all the observation falls on this range. The probability of this survival at this range is a 0.45. Okay, so I hope you get it. So this approximately, because when I go to Nelson Allen next week, okay, we also have another method to calculate the survival. With the same range, you may have the different answer. Okay, so do not panic. Different formula, different answer. The reason is because just approximate only. Okay, so any questions? So if no, then I move to next. Okay, let's go to example 2. So the next will be example 2, I think. Okay, let's carry on.
Example 2. Below are the losses suffered by policyholder of an insurance company given this data. Let X be the random variable representing the losses incurred by the policyholders. The observations are not truncated or censored. That means we don't have truncated or censored value. Use a Kaplan-Meier product limit to estimate the survival function for this data approximately. So this is the solution for example 2. Given X is a random variable representing this loss data. For J equals to 1, 2 to 10 here, so that means we have a 10 data. So let Yj denotes the loss values. You can see that some of the Y value are repeated, such like 49, 50. Since this question has no truncated and censored value, therefore Dj and Uj equal to 0 for all j. From the reset formula, you could see that since these two are 0, therefore the reset actually will be equals to this conditional for nxi, that is this. So we try to define for the xi, conditional nxi, and the conditional nxi, and also the ri, that is the reset. From this data here, we try to summarize and convert from the y to become the x, that is for the uncensored value. This is the distinct value for the x, that 49 repeat twice and 50 repeated 3 times, the rest are 1. The next, you have to count what is your nxi. You have to count what is the conditional nxi. So that means if you choose your x1 is 49, then how many x value which is more than 49 or equals to 49? Altogether, we have 10 data which is more or equals to 49, that is 10. And next we choose your x2 when it's 50. So for this conditional, that how many x value which is more or equals to 50, that is here. So altogether we have 8. So similarly, let's say I choose when my x5 is 80. So how many x value which is more or equals to 80? So that is here. So we have 3 values which is more or equals to 80. And the rest you should know how to count. So just because of just now without the truncated value and also the censored value, therefore our reset straight away is equals to the conditional for the nxi. That means this conditional nxi value, which is also equals to reset value. So how to get the survival function? From the Kaplan-Meier, so we name as a Km. So the survival function actually is in piecewise function, that for the first range is from 0 to 49. Then of course we always start from 1 for the first interval. Now from the second interval, that is from 49 to 50. So we have to use the formula that we have learned just now, that is this, which is equals to 1 minus nx1 divided by r1. So this one will be equals to the frequency or the number of observation for x1, which is equals to 2. That is this 2 divided by the r1, which is 10. So you have 0.8 for this case. Then how about the next range from 50 to 60? We will take the recursive formula, this recursive formula that you have calculated this 0.8 and just multiply 1 minus the number of observation for x2 divided by r2. So for this number of observation for x2, we have 3, and the r set value for the x2, which is 8. So 3 divided by 8. So you will have 0.5. And so on. So let's go to look at the last interval, that is 130 to infinity. Before this last interval, the second last interval, we have found this is equal to 0.1. For the last interval here, I'm going to use this result and multiply 1 minus nx7 divided by r7. So which is equals to 0.1 times 1 minus the number of observation for x7, which is equals to 1. The reset value for the x7, which is equals to 1 as well. So this becomes 0. The whole result should be this. So we solve this example 2.
Okay, last thing here. This example, the last interval, the survival is 0. Just now the example 1 is not 0, but this is 0. Okay, so do not worry. Some problem, the last interval will give the survival as 0. Some are not. Okay, do not worry, because this is just approximation. Okay, so I hope you know how to calculate. Okay, these two examples I think is quite clear. So maybe we go to next. Okay. So let's go to example 3.
Example 3. You are studying the length of time attorneys are involved in settling bodily injury lawsuits. Suppose the random variable x represents the number of months from the time an attorney is assigned such a case to the time the case is settled. 9 cases were observed during the study period, 2 of which were not settled at the conclusion of the study. For those 2 cases, the time spent up to the conclusion of the study, that is 4 months and 6 months, was recorded instead. The observed values of x for the other 7 cases are as follows. That is this data. Estimate the probability of this random variable x in between 3 to 5 using the Kaplan-Meier product limit estimator. So this is the solution. We let x be the random variable, represent the number of months. If you look at this question here, 2 of which were not settled. That means this is the censored value. So the censored value is false on 4 months and 6 months. This data is represent the number of months. So from here, very obvious that we do not have any truncated value. So therefore, the dj is 0 for all the j. Since the uj has a 2 censored value at 4 months and 6 months, and the rest are 0. In other words, the uncensored value at this 4 months and 6 months will be 0, and the rest are not 0. So in this case, if you look at the table, that is at the 4 months here and 6 months here, this censored value is 4 and 6. And the rest are 0. In other words, at the same time here, at 4 months here, the uncensored value will be 0, and the 6 month also, the uncensored value is 0 as well. And the rest will be the data from here, 1, 3, 3 until 9. So you need to know how to construct the table, otherwise you will not solve the problem. And next.
Okay, class, you have to know, really you have to know how to construct table. First, you have to see that this censored and uncensored value, it cannot be overlapped, right? So when this is 0, when this is not 0, this will be 0, definitely. When this is not 0, this will be 0, okay? And one more thing is the data here is referred to time, I think, so must be all in ascending form. You have to know some of the question they give the data. For example, let's say, let me go back to this question. Okay, so this is the data. Sometimes they will give you the data not in ascending. They simply put the sequence. So do you have to rearrange the data in ascending form? Okay, otherwise you got problem. Okay, so every time when you solve the problem, you have to make sure that this is your reference number. Okay, doesn't matter. Okay, of course your reference must be ascending. Okay, and this is the data given that must be in ascending form. Okay, so this is my y value. Okay, and we don't have d. We don't have d. So next you should know what how to calculate for the r. Right? Okay, let's carry on.
We have 3, which is repeated twice, and also the 8 repeated twice. The rest are just 1. So this is our x value, that is from 1, 3, 5, 8 until 9. Number of observations for each data of xi here. And you can see that this xi actually is distinct and also ascending. So remember, our xi actually also uncensored value, which is collected from the y. Okay, now we try to get what is the conditional nxi and also the conditional nui. So now we choose x1 is equals to 1, then how many x value which is more or equals to 1? So we have all, that is 7, which is more or equals to 1, that is 7. When we choose x2 is 3, then how many x value which is more or equals to 3? So we have 6, which is more or equals to 3. So and so on. And next we try to calculate the conditional NUI. So again we compare to the x1, which is 1. So how many u's value which is more or equals to 1? So the u value we have 4 and 6. So that means we have two values which is more than 1. And next we choose when x2 is 3, how many use value is more or equals to 3. So from here again, we have these two values, 4 and 6, which is more than 3. That's why it's 2. So next we choose x3 is 5. So how many use value which is more or equals to 5? From here, we only got one value which is 6, and which is more than 5, therefore is 1. So let's go to the x4, which is 8. How many use value which is more or equals to 8? Nothing. We don't have any value from the u which is more or equals to 8, therefore is 0. So when x5 is 9, there's no value from the u also more than or equals to 9, that is 0. So how to count the reset? Now for this problem, we have to use the Kaplan-Meier product limits estimator to find this probability. So when you want to use Kaplan-Meier, that means you have to count the reset. So here the reset formula, which is equals to the conditional nxi plus the conditional nui and then minus the conditional ndi. Since this problem we do not have any truncated value, so therefore this is equal to 0. So in this case, our offset value straight away, you add up these two. So that means you add up these two become the offset value. Right? So you just add up, and all those numbers here actually is a offset value for the corresponding xi value. Next, so this probability actually, which is equals to the probability when x is 3, 4, or maybe 5. So, and next we try to find the survival function under this Kaplan-Meier. So we need to find this survival. For the first interval, that is from 0 to 1, always is 1. For the second interval, that is from x to 3, so we have this formula that is 1 minus nx1 divided by r1. So the frequency of x1 that we have, which is 1, divided by the 9. So this is 1 minus 1 over 9 and equals to 8 over 9. For the third interval, that is from x to 5, we take the recursive formula that this result, you multiply the 1 minus nx2 divided by r2. This will be 8 over 9 and 1 minus. So we have found the result, that is 2 over 8. So you will have 2 over 3. And next interval, that is from 5 to 8. So we will take the recursive formula again, that is we will take 2 over 3 times 1 minus nx3 divided by r3. So our nx3 is 1 and the r3 is 5. So that means this is a 1 minus 1 over 5. So you will have 8 over 50. And for the next interval, that is in between 8 and 9. So we will take this result 8 over 15 times 1 minus nx4 divided by r4. So you look at the result, our nx4 actually is 2 and the r4 is 3.
Okay, class, here I want to highlight, when you want to calculate, please take this column, divide by r. Okay, some students go and take this divide by r. That's wrong. Okay, this condition frequency is to calculate the r. Okay, when you want to calculate the survival for the Kaplan-Meier, you have to consider this column. This frequency is for the xi. Okay, and divided by r. Please take this column and this column, not this, please. Look alike. Okay, it's highlight. Carry on.
I mean, this is 1 minus 2 over 3, and you will have 8 over 45. And the last interval will be 9 to infinity. So here you will try to get this result, and 1 minus nx5 divided by r5. So from the result we have found, that is become 1 divided by 1. That is 1 minus 1 over 1, which is 0. So this is our result for the survival function under this Kaplan-Meier. Now, our aim for this question actually is to find this probability. So this probability for this random variable x is between 3 to 5. So that means if you draw the line diagram, we have 3, 4, 5. We have to take this interval, and we have 2 and 6 here. So in other words, in order to change in terms of survival, so this will be equals to the probability that x must be greater than 2, because this is discrete, and minus this probability that x is slightly more than 5.
Okay, here some technical problem is really straight we jump to here. Now, now you have to understand that our aim is to find this probability. Okay, so this probability, because we have to convert to survival. So remember, survival must be strictly more than. There's no equal sign because this is discrete, very important. Unless this is a continuous, there is no problem. Okay, so because it's discrete, our x is the question asked to find for this range 3 to 5, including 3 and 5 here. So that means after 3 must be 4 and 5 because discrete, right? So for this interval here, in order to change to the strictly this inequality, strictly more than. So whatever x is equal more or equal to 3, okay, that is it's the same that x is strictly more than 2. Okay, because we don't have 2.5, 2.6. Whatever more than 2, straight away will jump to 3. Okay, so we have cover this left-hand side. So when come to right-hand side here, we have to include the 5. So how to change to inequality for strictly more than? So this is, of course, is strictly more than 5. Okay, so whatever this interval minus this, you will have this definitely. Okay, I hope you get it, because whatever is more than 5 will be 6. Okay, you cannot take x more or equal to 6 because for the survival you must have strictly more than. Okay, So understood for this interval, because we don't have 2.1, 2.5, so straight away we jump to 3. Okay, so for this interval, because it's strictly more than 5, actually it start from 6 onwards. So this interval minus this interval, you will have 3, 4, 5, definitely. So once you change to this already, then you can, this is my survival at 2, this survival at 5. So you go and choose your survival at 2. Okay, so 2 is here. Here, right? The 2 is false on the second interval. Therefore, the survival is 8/9. Okay, and next is a survival at 5. That is here, 8/15, because the 5 is false on this group. Therefore, you will take 8/9 minus 8/15. Okay, so you will have 16/45. This is a probability for this range. Okay, just for estimation only, class approximation. Okay, it's not 100% true. Okay, so any questions? So if no, I go to the last slide for this lecture.
Example 4. The claim payments on a sample of 10 policies are given by this, where you have a 5 plus, 7 plus, 10 plus, where the plus sign indicates that the loss exceeded the policy limits. Using the product limit estimator, calculate the probability that the loss on the policy exceed 8. So in this question, our aim is try to use the product limit estimator, that is Kaplan-Meier, to calculate this random variable x, which is represent the loss and exceed 8.
Now, class, can you see using the product limit? The question didn't mention the Kaplan-Meier. Understood. This is Kaplan-Meier problem. Okay, so you use a Kaplan-Meier method to calculate this probability. Secondly, you have to see the 5 star. Okay, 5 plus, 7 plus, 10 plus. The plus indicate the loss exceeded policy limit. Okay, so this policy limit, understood, is referred to the censored value. Okay, so I hope you get it. And we don't have a truncation for this problem. Okay, we only have the uncensored and also the censored value. Okay, 10 plus, all the plus sign here indicate the policy limits. That is your censored value. Okay, so carry on.
So first of all, we let the x be the loss random variable, and we try to define what is the uncensored value for y and also the censored value for the u. So for this problem here, we do not have any truncated value. Therefore, this dj always equal to 0 for all j. And we could see that here, this 5 plus, 7 plus, 10 plus actually is the policy limits value. So that means those values actually are the censored value, that is the u. So you can see that the 5, 7, 10 here are the censored value. The rest will be 0 for u. In others, for y, at 5, 8, and 10 here, this uncensored value will be 0. The rest are not 0, which is from here. So we will have this complete table for the uncensored and censored value. So we do not have any truncated value. That means our R set actually is equals to conditional nxi plus conditional nui and minus conditional NDI, and where this is equal to 0. So that means we only have this. So from here, we try to construct another table that is for the x. So from the previous uncensored value for the y, that this 3 repeated twice. So this is a distinct x value and also increasing. So what you want to find is all this value. So for the first one, that you choose your x1 is 2. So again, how many x value is more than 2? Definitely all. That is 7. The frequency is 7. Now if I choose my x2 is 3, how many x value is more or equal to 3? Definitely is here. That is 6. And again, of course, the rest you have no problem to count. Let's go to the u value. So compared to, let's say I choose x3 is 5. So how many u's value that is more or equals to 5? That is, you can see from here. So this is our u value. We have 1, 2, 3 value which is more or equals to 5. So we have 3 value which is more or equals to 5. Let me choose the x5 is 7. So how many u's value which is more or equals to 7? That you can see from her again that I have only 2 value, that is 7 and 10, which is more or equals to 7. So in this case, we have only 2 value which is more or equals to 7. And the rest should be no problem to calculate. So our reset value actually is equals to this plus this. You sum of this column and this column, you will have this reset value, which is corresponding to the xi. Before we want to calculate the probability, that you need to find what is the survival function for the under this Kaplan-Meier estimator. So for this survival, for the first interval that is between 0 to 2, we have 1. And for the second interval between 2 to 3, we have the formula which is 1 minus nx1 divided by R1. So you will have the number of observation for x1 actually is 1, and then divided by the R1 which is 10. So you have 9/10. And for the third interval, that is in between 3 to 5, you will take this result times 1 minus nx2 divided by R2. So you will have our nx2 here, that is become 2/9. nx2 is 2 and the R2 is 9, so it's become 1 minus 2/9. So you will have 7/10. And the rest you will get the answer that is become this result. Now for our aim for this problem actually is to find this probability that x is strictly more than 8. So this is actually is a survival at 8. But if you look at our solution here, that 8 is false on this interval, and our lower boundary is 7. So in this case, actually this is equal to S7. So therefore, so in this case, our result actually is 9/25.
Okay, so it's clear. So after you found the survival for this Kaplan-Meier, So you can calculate all the probability. Okay, make sure you have to convert to this notation as survival, and make sure must be strictly. So this is given by the question, strictly more than 8, so we will convert to the survival. But 8 actually is false on this group, so we can take the lower boundary as 7. Okay, so that means your S7 is equal to this. Okay, so that's it for this lecture today. And one more I want to highlight is I think you may ask me, should we every time to define all this? Okay, so you especially in exam you have no time. Okay, do not worry. You no need to. Up to you. You can, or you want or you don't want to define all this, no problem. But you need to define the x. Okay, you must let me know what is the x random variable. Okay, for the u, for the y, for the d, all this, we just assume that understood. We know the terms. Okay, so straight away after you define the x, you can go to the table. Okay, without define all this. Okay, and no need to define the condition as well. Okay, so no need to define, you can straight away to jump to the table. That is for your tutorial solution and also your test. But when you come to your assignment or your report, maybe when you work, so you may need to define clearly. Otherwise, people will query you. What is xi? What is d? They do not know maybe. So you need to define well for your report or project or whatever when you come to work. Okay. Okay, that's it for this lecture. So this Friday, we have a workshop, and again, because still got problem in that OD4, so you please don't go to OD4. So we fully online for this workshop hour for the yeah, because yesterday I have cancelled already. I do now. My question is, I just want to know that these two different workshop, are you free? What I mean is like, for those students in the workshop 1, do you have the other group? Do you have the class during the slot like yesterday, 3 to 4? 3 to 4 is for the group, workshop group, first group maybe, and then I need to know where the second group student, do you have class during the slot? Because okay, and at the same time also this Friday I think I forgot the time. I think it's 2:30 to 3:30, something like that. So during this workshop hour, okay, this is for the second group. So I want to know the first group, do you have class? Okay, this is very important to me. If you have class, if no class, you no need to tell me. If I have class, you just text me in this what do you call this, Microsoft. Okay, yeah, they say that Friday workshop, some of us got clashed with other class. Okay, because yeah, that means okay, Friday workshop clash lah. How about yesterday one, Tuesday? Do you clash with the workshop hour? Because I want to use the hour for your tests. Okay, if clash for these 2 workshop hour, then I have no choice. I need to use the lecture hour to conduct. Remember, in week 5, this is a week 3. Week 5 will have a quiz. Okay, you have a quiz for the what call this quiz 1. So that means in this case, oh, okay, Tuesday workshop class week. That means that means I have no choice. I have to use the lecture hours to conduct your quiz. And in other words, also this Friday, I cannot conduct the workshop because yesterday I canceled the class due to the technical problem. So this Friday also cannot conduct because I must on par for this two group. Otherwise, it's not fair to other group. I already report to IT department yesterday. So they will check for me what happened to the Audi 4. Okay, so so that means for your info, please. Okay, I hope you are still here. Yeah, 69 of you still here. So I want to confirm with you, double confirm with you. This Friday we have no workshop. Since yesterday we cancelled the class, so I have to do that also. But you do not worry, class. This tutorial this week I only discuss I think about 4 questions only. Okay, so you please come to my tutorial class. Okay, to discuss the remaining 4 tutorial questions or 5 from the tutorial 1. So we are going to have the quiz 1 based on tutorial 1 and chapter 1. Okay, are you clear? Okay, so so that's it, class. I hope you don't skip my tutorial class for this week because we are going to have a quiz based on tutorial 1. Okay, I think that's it, class. If no question, you may leave now. Okay, so please try your tutorial 2. Okay, I think for tutorial 2 only, I think you only can try 3 questions only. Whatever just involve the reset and also the Kaplan layer. Okay, so other than that, you don't try. Some question is mixed together with the Nelson and also Kaplan layer. That one you can skip. So you only try the question which is only involve reset and Kaplan layer. Okay, I think only 3 questions. Tutorial 2 you can manage so far. Okay, so I see you. Bye.